In this video, we're going to go over the Graylog challenge. You can get to this challenge after gaining access to the dorms, and if you talk with Peppermint Sticks, they'll let you know the login for the Graylog server, which is LFU student, LFU student. Um, if you click on the Cranberry Pi, at least for me, it doesn't render the Graylog server in the game. It does give you the questionnaire, however. So to connect out to the Graylog server, I do inspect the code and directly connect. So after you get out there and you get authenticated, we can go into the all messages, set our time for all, and start looking at the questionnaire. Now, since we're not doing this from within the game, you want to make sure to write down all of your answers so you can submit it there for credit, because just submitting it here won't get you credit for the challenge. So looking at this incident response report, we know an incident definitely happened on the LFU network, and it looks like they got compromised to the point where data got exfiltrated. So let's help them figure out what happened exactly. So question number 1, Minty Candy Cane reported some weird activity on his computer after he clicked a link in Firefox for a cookie recipe and downloaded a file. So that comes with a lot of information that gives us a good starting place. So we know the user was Minty Candy Cane, we know that he was running Firefox, and we know he downloaded a file and it was pertaining to a cookie recipe. So we need to find the full path and the file name of this malicious file. So let's start by looking for file rights. So we can do that by looking for event ID 2. And since we know it was in Firefox, we can say process image and give it a regex that's going to match for Firefox. Okay, and we got data, which is good, but it's a little bit too much data. It's hard to tell what exactly is going on. So by default, in any browser, the download location is going to be C user's download. So we can add that to our search just to see if that's where he put it. And we do that by saying target file name. And again, give it a regex that's going to match. There we go. Now we have one event. And if we look at this, we can see the target file name is cookie recipe, which makes sense since he was looking for a cookie recipe. So let's take that and submit it and see if we got it right. And sure enough, we did. Awesome. So let's make sure to write down our answer. Okay. And moving on to question 2. The malicious file downloaded and executed by Minty gave the attacker remote access to his machine. What was the IP and port the malicious file connected to first? Okay, so we know the file name. So what we can do with that is we can look for that as the process. So we just add that so it does all of the escaping for us. We just overwrite target file name with process image. Oh, whoops. Let's do that correctly. Okay, and now we can see a few events here. And let's go ahead and check the command line so we can see that. Okay, and it wanted the destination IP and port. So if we check those, these events don't have it, but this one does. And it looks like we're connecting out to this 175 address over port 4444. So let's try that. Cool, so that was it. So we know the attacker connected out, and now they have an interactive shell. So what was the first command executed by the attacker? So what we can do in Graylog is pivot off of this last event that we know is good, and we can say check surrounding messages. So let's go ahead and do that for 30 seconds. Okay, and we still have command line checked, so we can go ahead and say quick values on that, and that'll throw this up here. We can see who am I running and cookie recipe running. Now who am I is typically something that you would run immediately after getting a shell, And actually, if you look at our event, here's the network connection that was made that we had already found, and then the next command that's run is who am I. So let's try who am I. Yep, sure enough. Alright, question 4. What is the one-word service name the attacker used to escalate privileges? Okay. So it looks like, looking at this, they're running stuff out of the cookie recipe. So let's make sure we're looking for that as the parent. Go ahead and clear our time filter to just say all time. Okay. And let's just walk through it. So we see the who am I running. They did an ls of C. Keep going. They're poking around services with SC. They're grabbing cookie recipe 2. That looks important for later. And then they start doing something with WebEx service. And they're spawning that cookie recipe 2 from it. So let's try WebEx service. Yep. Okay, so we know that they've escalated and we know that they're running cookie recipe 2 now. So what is the file path and file name of the binary run by the attacker to dump credentials? So since they're now in cookie recipe 2 instead of cookie recipe blank, let's go ahead and change our parent process to that and see what they're doing. And let's clean up our quotes in the search, so we don't need those. There we go. So scrolling to the bottom to see the first events. See cookie recipe 2. They run who am I again. Print working directory. And then they start pulling down Mimikatz, which is super common for dumping credentials. It looks like they tried to do it a few times. Maybe it's not working for them or something's blocking it. And keep going through. And then we see cookie exe running, and it's trying to dump passwords as well. So let's try submitting cookie.exe. Oh, it wants the full path, which is just C. There we go. And just to show that that is Mimikatz, down here in one of the invoke web requests, we see them outputting to cookie exe. So we know that now they have the credentials that were on that box. The attacker then tries to pivot to another workstation from Minty's computer. So let's find out what that was. So we know they pivoted probably with RDP, so we can look for a 4624 event, which would be a successful login. And since we know the attacker's remote IP address from that initial connection that was made, the port 4444, we can search for that. And that was 192.168.247.175. Okay, we see a few events, so we know there's definitely some traffic there. And let's take a look at the logon types, and we can do a quick values on that. And we see a lot of 3s and 110. So the 10 is the one we're interested in because that is a remote interactive logon. So let's add that. And let's figure out the user. I believe it's account name, yeah. So they used Alabaster. Okay, so we know they've pivoted to another machine from the attacker's machine. And let's see, I just want to expand some of these. Okay. So we know they came from another machine. They used Alabaster's account. When did they make the connection to his machine? So that was at 6:04:28. Okay. And after they gain access, they navigate the system of a third host using the remote desktop connection to the second. So they came from whatever host they just authenticated to and went to a new machine. Okay, so we know they came from this host. So let's add that into our source host name. And we can clear this. Okay. We don't need this right now. So we can open up another quick value for the destination. So they came from this one. So it looks like they're on this host now. Add that to our search. And the other thing it wanted was the logon type. The only logon type there is logon type 3. So we just need to put all of that together. Source name, destination, and logon type. So just clean this up a bit. And 3. There we go. What is the full path and file name of the secret research document after being transferred from the third host to the second host? Okay, so we know it's being transferred from one host to the other, so we can expect a file write to happen. So let's add that back in. And we know it's going to the second host, so workstation 2. So we have 2 points to go off of. So let's go source. Let me clean this up. So we're going to say source workstation 2, and event ID is 2. And let's just get a nice chart of the target file names. Okay, and we can see that returns a little bit too much data. So one thing we can do is we can use the time frame to kind of squelch this down a little bit. So if we go back and we go to this event, or any of the events really, and we just say show surrounding messages, and let's just say 30 seconds here. Okay, and then change our source. Try our search again. Alright, that's much cleaner. And let's show the target file names. And that's kind of hard to read. Let's throw it into a quick values chart. And we can see super secret elfu research.pdf. So it's probably that one. Got it. Cool. And then one question left. What is the IPv4 address? It's found in the logs. The secret research document was exfiltrated to. Okay, so let's pivot off of the file name and see what we can see. Go ahead and add that to our search. Clear this and fix our time. We can leave the start time. We just need to extend the end time. This isn't really showing me what I was hoping to see. So let's go ahead and go back and rethink our approach. So we know that file got exfiltrated somewhere. So we know it's now on workstation 2, so it definitely needs to be on that host, so we can add that to our search for sure. We don't need this event ID 2 anymore, so let's take that off. Look at this event. Destination host name. So that's the attacker's destination IP. And funny enough, his host name is definelf. But I'm still not seeing anything that's really showing us where the exfil is. go ahead and fix this. There we go, that looks a little bit better. So now we can see, let's go ahead and search for secret. So now we see a PowerShell command being run, and it's connecting out the paste bin, and it's posting our super secret LFU research paper. And the next event has destination IP and the destination port. So let's see, is that the right IP address? It is. Awesome, we did it. We fully detected the incident. So like I said before, we didn't get credit because we're directly connected out to the server. We're not in our game, so we need to resubmit all of our answers, which only takes a second. And there we go. We got credit for the challenge.